now turn to a general survey of factoring. In general, you always want to ask the question, can I factor out a greatest common factor? That is the most important type of factoring because we have to do it so often, and it always should be the first step every time we try and factor. Then we look at how many terms we have left. If there are 4 terms, I say try the grouping method. Usually that will work either with a 2-2 split, a 1-3, or a 3-1 split. If there are 3 terms, I suggest trying to unfoil the expression, and that means just break it into your 2 parentheses. If there are 2 terms, I suggest trying the difference of 2 squares as your first method of attack. And if it isn't the difference of 2 squares, I can spell that, then it would be the sum or difference of 2 cubes, most likely. Not always, but most likely. And then we tend to overlook at this step, but the question you should ask also is, can I factor further? Can this baby be broken down any further? So often people miss their factoring problems on tests because they don't factor completely. Okay, now we have a few problems that we're going to look at, which is just a summary of all these different methods. Here we go. First one. First question, can I take out a GCF? Yes. 2 goes into both terms. Dividing it out, we have a squared minus 81. Looking inside the parentheses, we see 2 terms. That tells us it's likely going to be the difference of 2 squares, which it is, a plus 9 times a minus 9. No more squares. If that was a squared minus 9, we could break this down further in the difference of 2 squares, but that's not a square at the beginning, a there. Okay, next problem. Is there a GCF? Yes. 3 can be divided out, leaving us with q squared minus 3q minus 4. Now we see 3 terms inside the parentheses. I'm going to factor it using the Unfoil method. I see there's just a q squared in front, which means it's got to be q times q. 2 numbers that multiply to 4 and add up to 3, add or subtract to 3, are going to be 4 times 1. I want a minus 4 and a positive 1, so that the middle 2 terms, the minus 4q and the plus 1q, will add up to that minus 3q that's in the middle of the problem. Number 25 here. You could rearrange that into descending order, which I'm going to do. You could have just left it as is and factored as you saw it. I'm going to see that there's just a k squared, no number out in front, so I'm going to factor that into k times k. And then I'm going to have a plus 8 times a plus 8. Rewriting that as k plus 8 quantity squared. If at the original problem you had wanted to go 8 plus k times 8 plus k, well, addition is commutative, and that would have been equivalent to this answer that we have here. Okay, next problem, number 10. Slide that to the left a little. GCF of 5. Factor out of 5, and we're left with r cubed plus 1. And r cubed is a cubed, 1 is a cube. So I'm going to factor that further. Use the same sign in the first parentheses, r plus 1. The second parentheses will begin with the r squared. We then have the opposite sign, switching to a minus. We're going to have 1 times r, making 1r in the middle, and then 1 squared, always positive at the end, plus 1. Done. Problem number 30. Okay, we say to ourselves, is there a GCF? No. Hey, 3 at the beginning, that's a prime number. It's going to have to be a 3y times a 1y. 1 at the end, it's going to have to be a 1 and a 1. But no matter how you play with it, you got a 1y and a 3y. Those won't add up to a 1y in the middle. This is not going to work, and this expression is prime and cannot be factored. And that happens every once in a while. Number 35. A GCF of negative p can be factored out. That leaves us with p squared plus 5p plus 4. Notice how the signs in the middle changed when I divided by a negative. Out in front we're going to have a negative p, and then inside p times p will create that p squared, and 1 times 4, or 4 times 1, will create the 4 at the end, and the 4p and the 1p will add up to the 5p, checking that inner and outer. If you want to draw those little loops there, you can. Okay, next problem. GCF, no. I do like the 2v squared at the end, because 2 is a prime number, and that means I'm going to have a 2v times 1v if this factors at all. So now I've got to play with that 14. I don't think 14 and 1 will work, or 1 and 14. I'm going to try 7 and 2. If I put 7u and 2u in there, then in the inner terms I've got a 4uv, and then on the outer terms I have a 7uv. And if they're both negative, that will add up to the minus 11 in the middle and have everything multiplied to the positive 2v cubed at the end. So I'm going to put a minus in the middle of each of those parentheses and call it done. Okay, number 55. GCF 25 can only be broken down by 5, and 5 won't go into 81. There's no u's or v's in all three of the term. Okay, that's about as far as that's going to go. I'm going to try the 9u, 9u split, because I see the perfect square. And I'm going to try the 5v, 5v split. Both signs have to be the same to multiply to the positive 25, and if they're going to make a minus 90, they better both have the same sign in the middle and both be negative. Now in the middle I get a negative 45, on the outer I get a negative 45, and those do add up to the minus 90, so I did do that correctly, and I'm going to write this now as a binomial square, 9u minus 5v quantity squared. Number 65. I'm going to factor out a greatest common factor of 3, leaving me with 4x squared minus 4x plus 1. I'm going to break it down further. I see a trinomial. It ends in a 1, so it has to be a 1 times 1 at the end of the parentheses. I'm thinking same thing in both parentheses, 2x and 2x. That makes the 4x squared. If both of these are minuses, that multiplies to the positive 1, and the middle terms are each minus 2x adding up to the minus 4x. We're good to go. We're going to rewrite this as a binomial square with a 3 out front. 3 times 2x minus 1 quantity squared. Okay, now you're on your own here to try all these multi-step factoring problems.